Hello everyone, this is Mr. Underkoffler once again, and today we are looking at the guided notes called Using Number Lines with Addition of Integers. Alright, follow along with me as I read the opening statements out loud. It says number lines can be used to model addition symbol problems of integers. When I say model addition symbol problems, I mean to visually represent these addition symbol problems. Addition symbol problems just mean problems that have a plus sign, okay, in between the numbers. So I'm not trying to make this complex, just want to make sure you understand what I'm talking about. Continue following along. It says to use a number line with addition symbol problems, here's the game we're going to kind of play with number lines. We're going to start at 0. If the first number in the problem is a positive number, or if any number is a positive number in the problem, we will go to the right that amount to represent that positive number. In fact, we're actually going to draw like an arrow with that, okay? A line, but with the tip at the end going in the right for that positive number. For a number that's a negative number, we're going to go to the left above the number line, that amount. Again, drawing a bar, but, putting an arrow at the end. Then the fourth thing, we're going to put a dot on the number line at wherever we end up after we've gone to the right or left, or maybe right twice or left twice, or whatever we have to do for the numbers in the problem. Once we're done, we will figure out where we are and put a dot on the number line at that final answer. Examples: use the steps above, these 4 steps here, these rules, to find the answer to each problem. Now, I already know that numbers 1 and 2 are already done for you on your guided notes. I know, but I want to talk you through how they actually work. So, number 1, we have -7 plus -4. Now, you might be wondering why the -4 is in parentheses. The parentheses don't really matter if there's only one number inside. The only reason they're using parentheses here is because you'll notice that -4 obviously has the negative sign, right? Which can look like a minus sign. And if you had a minus right next to a plus, that obviously would look confusing, wouldn't it? So what textbooks across the world, from my understanding, what textbooks and worksheets will do is for any number that comes to the right of addition, subtraction, multiplication, or division, if that number to the right is negative, they'll put the negative in parentheses, so that way you don't accidentally think that the negative is a subtraction symbol. That's the only reason that -4 is in parentheses. So, nothing really to worry about here. So, let's go to the rules. We're going to start at 0. And you will see I start by putting a vertical bar coming up here from 0. So that's what I always do at the beginning of these problems. Then I look at the very first number. The very first number is -7. So what do I do if it's a negative number? I will go to the left that amount. So here I am drawing a bar, putting an arrow at the end because I'm going left. And let's label it -7 because that's what it is. Now, what's the next number? -4. Negative numbers, again, they go to the left. So from the end of the previous number's arrow bar, from the end of that, is where you're going to do the second number's direction. Not from 0 again. Now, I apologize I didn't put this up here in the rules, but that second number should be done at the end of where the previous number's bar had ended up. So from this bar, I will go left 4 more spaces. 1, 2, 3, 4. You kind of have to count the spaces here. 4 spaces to the left. Now, where does that put me? Boom, at -12. So I place a dot where I end up. I hope you guys all saw the dot. It was already there because, again, I told you this problem was already done for you, wasn't it? But I'm talking you through it. And so once I find out where I end up, then underneath the original problem, boom, I write down the answer, -11. Circle it if you want, and that's how you can use these rules and number lines to model, meaning visually represent, these addition symbol problems of positives and negatives. Problem number 2. Now this one has a real life scenario to it. Clinton Portis, which by the way is a former running back of the Broncos and the team from Washington. Clinton Portis lost 5 yards on his first play. Bummer. Lost 5 yards. Then he gained 8 yards in the next play. What were his total yards, lost or gained? Now again, this is part of the directions to use the rules that I showed above with the number lines to model this situation to find the answer. But before we do that, we should kind of write out what we actually have here. A loss of 5 yards. That would be -5. And since our guided note said that we are doing addition symbol problems, then I need to make sure I put a plus sign next. Now, it says from here that Clinton Portis gained 8 yards on his next play. So if he gained 8 yards, then we need to have +8. So this is the math problem that we should write out to represent the scenario before we actually model it above the number line. Okay, from here, always start at 0. So put a bar straight up and down from the 0. You see I did that. Let's take the first number, -5. -5, which way do negatives go? To the left. So I will go to the left 5 spaces, and I will label that bar -5. Make sure you put a tip at the arrow at the end of the arrow because you're going left. Count 5 spaces to the left. There's -5. But then from there, we're gaining 8 yards. Now remember, the second number, the +8, you don't start at 0 anymore. The second number, you start at the end of the first number's bar. But +8 doesn't go to the left, does it? It goes to the right. So what I'm going to do is I'm going to kind of scooch up here a little bit and put my next bar above the other one, since I kind of have to show that I'm now going to the right. I don't want to draw over the -5's bar. So I'll go a little higher here and then count 8 to the right. Now this is not going to take me past 0, isn't it? And if I would count correctly, this would leave me at the value of 3. So I put my dot at 3. Now, the problem said what were his total yards lost or gained. I think we can all agree that if you're ending up at +3, that's not a loss for the total net here. That is a gain. So I just simply write out his total was 3 yards gained. Real life problems should have real life answers. My final answer isn't just 3. My final answer to this real life scenario problem is that it was a 3 yards gained. And that is 2 examples of how we can model number lines or model above number lines using these rules to represent these problems. Okay, problem number 3. Let's do this together, piece by piece. It says Eva deposited $12 the first day. Now, do you remember the bank terminology that I taught you guys on a previous page of guided notes? If you deposit 12, that is money going into the bank. If it goes in the bank, into your bank account, that is going to increase the value of the money that you already had in your bank account. Therefore, depositing $12 is a positive $12. It's almost like deposit. It almost has the word positive in there. So that might be an easy way for you to remember that. The next day, she made a withdrawal of $20. Write an addition problem using integers for each transaction. Okay, transaction just means what's going on here, the depositing and the withdrawal, the stuff we do at the actual bank. Now, it did say an addition problem. That is in the directions. So we have to make sure that we put a plus sign between the numbers that we write. We already talked about how depositing 12 is a positive 12, so that's already written down. But what about the withdrawal of $20? When you withdraw money from your bank account, that takes it out of the bank account, which makes the money that you used to have in your bank account now become less. Therefore, a withdrawal is a negative number. Now, as I showed on problem number 1, textbooks across America and across the world, if there's a negative number coming to the right of an addition, subtraction, or multiplication or division symbol, then textbooks across the world will put that negative number in parentheses. However, I'm going to be honest with you. If you would like to write it like this, where the negative number is a little bit higher, the negative sign's a little bit higher up, that also would show me that it's -20 instead of a minus sign and then 20. I will accept that this school year if you would like to not use the parentheses for negative numbers that come to the right of addition, subtraction, multiplication, or division. I'll leave that up to you. You decide which way you want to write it. But please understand, Textbooks and worksheets across the world will do the parentheses if there's a negative number to the right of some other kind of mathematical symbol. Okay, with that all being said, let's now do part B. We're going to use the number line to find out the balance. The balance means the final amount of money in the bank account. So I apologize if I never really defined that for you guys clearly before, but that's what balance means. It's the amount of money that remains after the two transactions, after the deposit and the withdrawal. They're the two transactions. Okay, let's follow the rules. The rules say that we start at 0. So let's put a bar going straight up from 0. Doesn't have to be perfect, just as best as you can. Now, the first number is 12. Which way does a positive number go? It should go to the right. So we're going to put a bar going to the right. Let's label it. That was positive 12. The next number is negative 20. Which way do negative numbers go? They go to the left. But where do I draw it from? From the end of the first number's bar, which was here. But if I need to go left now, I'm going to have to show that above where I just was. So put a little vertical bar here above, and then from there, go left 20 spaces. And I mean, again, this doesn't have to be perfect, but something like that. Label it 20. Now, you are going to have to count. Forgive me for saying it shouldn't be perfect. It should be perfect enough that you can count the number of spaces correctly. So if you count 20 spaces, double check this for me. The first 12 of those spaces takes you to 0, and then there'd be, what, 8 more spaces remaining, right, to get to the full 20 spaces to the left? And so that should put you at negative 8. And so the final answer to this problem is that we should be at negative $8. So let's write that down somewhere, okay? We're going to be at, put a dollar sign, and then negative 8. There you go. That is the answer to problem number 3. Okay, problem number 4. Mary ran a lemonade stand. She spent $14 on the ingredients. Her sales of lemonade drinks totaled $10. Part A, write an addition problem using integers for the situation. All right, I want you to try to do part A on your own. You have to figure out if the money that she spent, the $14 on ingredients, if that's going to be a positive or negative. And then you got to figure out if her sales of lemonade for $10, if that's going to be a positive or negative. So make the interpretation for each of those two integers and write down the addition problem for part A. So hit pause, do that quickly, then hit play to see how you did. Okay, I hope you did that. Let's see how you did. For $14 being spent, that is going to be, oh, forgive me, I just hit the wrong key here. That is going to be, well, think about this. If you're spending money, that's coming out of your pocket, right? That's coming out of your account. So you're losing that money. It's going to the store where you're buying the ingredients from. So that's going to be a negative 14. Now, it has to be an addition problem, so you put plus. Now, the sales for the lemonade, meaning how much money that you got from selling the lemonade, is that going to be positive or negative? Well, that's money coming from the customer to you. That increases your money, right? So that's going to be a positive $10. So it's negative 14 plus 10. And the negative 14 does not need to be in parentheses. It's the very first number we wrote. We're not going to be confused. We're going to know this little dash here is a negative, not a minus. It can't be minus. There's nothing to the left of it to subtract it from. So that's a negative 14. We don't need parentheses. Okay, part B. Can you do this on your own? Let's see if you can. Hit pause on the video. Do the modeling above the number line, just like I've been teaching you on part B of number 4. So hit pause, do part B, then hit play when you're ready to see how you did. Okay, I hope you did part B on your own already. If not, hit pause now because I'm about to go over it. You should have started at 0. So we put a bar straight above where the 0 is. First number is a negative 14. You should have gone left 14 from that 0, something like this. And let's make sure we label it negative 14. Now from here, we have a positive 10. Positives don't go to the left. Positives go to the right. Now, since I'm going to the right, that's the opposite direction of where I was going. So you're going to have to put a bar above where you ended up from the previous bar. And then from there, we're going to the right 10 because it's positive 10. Something like this. Label it positive 10. Where does that put us? If you count correctly, it should, forgive me, that should put you at -4. So let's write out the final answer. The final answer is supposed to answer, right here. Whether she made a profit, which is a gain, or a loss. Well, let's see. If it's -4, then we're going to say that it's a loss of $4. Now, notice I didn't say a loss of -$4. The word loss means the negative sign, doesn't it? So you don't want to say a loss of a negative, because then that's like a double negative, which is actually a positive. So we're just going to say a loss of $4 to represent the -4. That's the real life answer for this real life scenario. All right. We are now at problem number 5, part A, part B. Would you please hit pause on the video? I want you to do part A on your own quickly. Read the problem. Let's see if you do it right. Hit pause, do part A. All right, I hope you did part A on your own. It said the temperature at noon was -4 degrees. Obviously, that's -4. The next hour, it dropped 5 degrees. Now, it did say write an addition problem. So you got to put plus. It says an addition problem. Got to follow the directions. But if you're dropping 5 degrees, how do I represent that? -5. Again, if you don't want to use parentheses, then you may write the -5 with the negative sign written a little bit higher up to the left of that 5. That way we'll know it's not a minus sign, it's actually a negative to the left of the 5. Or you can use the parentheses like I was telling you before. Either way is fine. All right, so that's part A. Part B, hit pause on the video, do part B on your own, and then hit play when you're ready to see how you did. Okay, I hope you did that. I hope you hit pause and already did part B. If not, do that now. Do it on your own. I am now going to go over it. Okay, did you start at 0 and gone left 5? Or sorry, left 4, forgive me, the first number was -4, so left 4, and then from the end of that -4's bar, you're going to go left 5 more, because they're both negatives, kind of like problem number 1 at the top of these guided notes. So where will that put you? At -9. What's the final answer to this problem? What's the temperature? That would be -9 degrees. Yes, you must say degrees, because that's what this is about. It's temperature, it's degrees. We don't really know if it's degrees Fahrenheit or Celsius, but we do know it's degrees. You could put the tiny little O on the top right-hand corner of the -9. That's the symbol for degrees. So if you did that, I am going to accept it totally fine. Okay, these guided notes finish with 3 problems. They're not real-life scenario problems. They're problems where the original addition symbol problem's already given to you, and we have the number lines that you need to do the modeling above. So definitely hit pause on the video. Do 6, 7, and 8 on your own. Once you're done with those 3 problems, then hit play so we can see how you did. So hit pause, do 6, 7, and 8 on your own. All right, I hope you did 6, 7, and 8 on your own, because I'm now going to go over it. Number 6. You should have gone left 9, then left 5 more, because they're both negatives, kind of like number 5. That's going to put you at -14. Make sure you write it down somewhere, circle it. That's the final answer. You could have written that underneath the original problem like I was showing you on problem number 1. My apologies that I didn't do that. But there you go, -14. All right, number 7. We had a +11 and a -3. So start at 0, go to the right 11 because a positive goes to the right. From the end of that bar, we have to go left 3. So I have to kind of show that a little bit above to show that I'm going left since the first bar was going to the right. So left 3, if you count back 3 spaces from the end of the 11, that should put you at +8. So the final answer is 8. And finally, we get to problem number 8. We have a -4 plus a +10. Let's see how you did. Again, start at 0. The first number is negative, so we go left 4. The next number is positive, so we have to go to the right. So I'm going to put this a little bit higher from the end of my -4's bar. So above that, I count 10 to the right. Now, make sure you count correctly. The first 4 spaces of those 10 will bring you back to 0. That's going to give you 6 more remaining spaces because we know 4 and 6 makes 10. So that's going to put you 6 spaces to the right of 0, which of course is at +6. That's where your dot goes. Final answer is 6. Now, I wonder if some of you have discovered that there's another way to find answers to these addition symbol problems of positives and negatives. There's another way, a quicker way, that you can do it without using number lines above, without using bars above number lines. And so now's the time where I want you to try to explain how would you do these kind of problems without number lines. But we're going to split it up into two groups. And I'm actually pulling these questions from your textbook, which I never ended up giving you, but no matter. I could have made these questions on my own. The first one says, what rule can you use? You might have to explain the rule in like more than one part. That you could find the sum. Sum just means there's an addition symbol in between. Of two negative integers. They say without using counters. They're talking about the bars and everything with the number lines. So how could you do the problems where they're both negative integers? So like number 6, they're both negative, right? How could you do that problem without the number lines? What was another problem? Oh, yeah, right there it is, number 5. That was another one where both numbers were negatives. So look at number 5, look at number 6. Can you find a way of doing those problems where they're both negative without using number lines? Hit pause in the video. Can you write down maybe a sentence or two explaining what you could do without number lines for problems where they're both negative? Hit pause, do that please. Write a little sentence or two. All right, let's see if you were able to figure that out. If they're both negative, do I like add in my head or do I subtract in my head? Well, it appears if you look at number 6 or if you look at number 5, to get the answer, I think we can all agree we'd have to add in our head, wouldn't we? Right? 4 plus 5 is 9. Or on number 6, 9 plus 5 is 14. Yeah. If both integers are negative, then you're going to add in your head. And then I think the answer is just going to stay negative, isn't it? So did you write something like that you would add in your head? Technically, we say you're adding their absolute values. Absolute values, remember how absolute values always become positives? So it's kind of like you're taking away the negatives, adding in your head, and then the final answer, the sign, will be negative. You don't have to write word for word what you see here. It says sample answer. Bottom line, if both numbers are negative, you could add in your head without the signs, add their absolute values, and then the final answer would stay negative. But what about the other scenario? Could you write a rule where you're finding the sum, just means an addition symbol in between, where the one number is positive and the other number is negative? So that would be like number 7 or number 8. Or what else do we have that was like that? Oh yeah, number 4. That was another one. Where the one number is negative, the other number is positive. Can you write out a set of rules that you could do without number lines for those kind of problems? Hit pause, do that now. All right, I hope you've done it. Did you write out some sentences to explain how you could do these addition symbol problems where the one number is negative, the other number is positive? Do we add in our head like we did when both numbers were negative? No, because if we did, we would have gotten like 24 or negative 24, right? It doesn't appear we're adding in our head on this, are we? If the one number is negative and the other number is positive, we're going to subtract, aren't we, in our head, right? Because that's what you would do on number 4 without using number lines. Same thing on numbers 7 and 8. We have a positive and a negative, right? Or a negative and a positive. Looks like we're subtracting in our head. Yeah, 11 take away 3 or 10 take away 4. We are definitely subtracting in our head if we're going to do those problems without number lines. Is the answer always positive? Well, it is on number 7 and 8, right? But what about number 4? Oh, that answer was negative. So did you somehow explain how you know if the answer is positive or negative? If the negative number has a longer bar, now how can I describe that in words? If the negative number has, how about a bigger absolute value? If the negative number has a bigger absolute value, the answer is negative. But if the number that has a bigger absolute value, a bigger bar, if the number with the bigger absolute value was the positive number, like it is here on problem 7 and problem 8, right? The 11 has the bigger absolute value, the 10 has the bigger absolute value, then in that case, the final answer is going to be positive. Did you somehow explain this in your own words? Like I said, we're going to subtract in our head. We're technically subtracting the absolute values. The sign of the answer is going to be the sign of the integer that had the bigger absolute value. So again, if the positive number wins, so to speak, if the positive number has the bigger absolute value, like on problem 7 and problem 8, then the answer is positive. But, like on number 4, if the negative number has the bigger absolute value, if the negative number wins, so to speak, then the final answer will be negative. Ladies and gentlemen, I am going to give you those official rules that I just spent the past like 4 or 5 minutes talking about. I'm going to give you those official rules on the next packet of guided notes, so that way you don't have to worry if you didn't have it written out perfectly. I will give it to you perfectly on the next packet, but I wanted you to see where the rules came from. We didn't just make them up out of thin air. We actually discovered them using these number line problems to kind of lead us to those rules, which I think is kind of cool. All right, guys, thanks for watching this video. We'll see you next time.